Hello, this is Esma Ollie, and I am part of Group 8. This is my final project or final exam, you might say. We chose option one, the multi-threaded Looney Tunes race game using POSIX thread. Uh, Here's a quick README that I did. Um, it just kind of has an outline of everything that will run the game mechanics of this game. And so we have an overview, just some game rule mechanics, some M- Marvin mechanics, which I will be going into detail afterwards, and then how you compile it. And then here we have our files just committed on here. Um, and then this will also be added into the Google Slides, so you can look into it better. Anyways, let's move on to the code itself. So here is our code. Everything is in a single file, race game. And so I also have a description where I kind of just outline the code and what is going to be shown in here. At the top I include I include the libraries I need, and I define the board size, the number of players, and numeric IDs for each character. The characters being Bugs, Taz, Tweety, and Marvin. I also define a player struct that stores each runner's symbol, their current row and column, whether they're still alive, and whether they're carrying a carrot. For the board itself, I use 2D arrays. Um, right here. Board items keeps track of what's on each cell, a dot, a caret, stands for C, or C stands for carrot, and then F stands for mountain. Occupants stores which player index is standing on that cell, or -1 if that cell is empty. And then I have a global array of players, some game state flags like game over, winner, and counters for moves and cycles. And then a pthread mutex, board mutex. Uh, I feel like I butchered that, but it's okay. That I use to protect all the shared state, so only one thread at a time is updating the board. So moving on to the in-depth of the code. Smooth. Let's see if I could find it quickly, that would be awesome. Okay, here it is. So, in the init board, I cleared the board, set all the players to alive with no carrots, and then place them at fixed starting point positions on the 5x5 grid. I also placed two carrots at fixed locations and the mountain at the top right corner. Then I print the initial board so you can see the starting state. In main, um, here is the main. In main, I seed the random number generator, call init board, and then create four threads, one for each runner. Runners being, again, Bugs, Taz, Tweety, and Marvin. Each player runs the same runner function, but gets a different ID so it knows which player it controls. After creating the threads, main waits for all of them to finish using pthread join. And at the end, it prints out which character won based on the winner index. So moving on to the runner function, which I will actually have to find that. Here it is. So inside the runner function, each character has the ability to pick a random valid direction, which is up, down, left, or right. For each move, I lock the mutex, check if the game is already over, or if this player has been eliminated, and then I compute all legal moves from their current position. I filter out moves that go off the board, moves onto mountain if they don't have a carrot. And for non-Marvin players, I also block players. Uh, I also block moves onto other runners. Only Marvin is allowed to step onto another player. And so once a valid move is chosen, I update the occupants array to move the player, handle picking up carrots, check if they just reached the mountain with a carrot to win, and then I update the move counters and print the board after each move. And then now moving on to Marvin's cheat code or his special mechanics that he has. For Marvin specifically, inside the runner, I check if his next cell has another player, and if it does, he shoots them. I mark that player as not alive, clear their spot, and if they were carrying a carrot and Marvin doesn't have one yet, he steals it. I also keep track of how many moves have happened in total. Every uh, every 4 moves is one full cycle, and after every third cycle, if the game isn't over, I call move mountain. Um, that function removes the old F and randomly relocates the mountain to a new empty cell with no player and no carrot, simulating the time machine um, mechanic from the assignment. And so that is the basic program that we have here. Just like a quick outline of what the code does before we actually run it. So I've actually ran the game already, but I will be running it in front of you as the viewer, just so that you can see how it runs and we can go through what is happening while it runs. So here it is running. Um, Here you can see the 2D board printing repeatedly B, D, T, and M, which are the 4 characters again. They stand for Bugs, Taz, Tweety, and Marvin. Um, C represents the golden carrots, and F is the mountain. Each character is running in its own POSIX thread, and they move randomly around the board. When a character steps on a carrot, I mark them as carrying it, and then they're displayed like BC or MC. Marvin is allowed to land on other players when that happens. He eliminates them, and if they had a carrot, he steals it. After enough moves, when the time machine condition is met, the F symbol moves uh, to a random, to a new random empty spot on the board. Sorry about that, brain glitch. The race ends as soon as one player steps on F while carrying a carrot, and then the program prints out which tune won. So here you can see the winner message printed with the character symbol and their name, which in this case is Marvin. Um, Overall, this project uses 4 POSIX threads, sharing one game board and mutex to safely synchronize all updates to the shared state. It shows how to manage concurrency, avoid data races, and implement game logic with multiple threads in C. So that's my demo. Thank you.